Historically, paleontologists viewed the transition from the Jurassic to the Cretaceous as a period of severe decline for marine reptiles. This phylogenetic model illustrates that assumption, depicting a wide array of Jurassic lineages narrowing into a single evolutionary bottleneck. For years, researchers identified the robust cosmopolitan genus Platypterygius as the only significant lineage to survive and dominate this later era. A fossil specimen recovered from the late Barremian strata of western Russia challenges the idea of a depleted Cretaceous ocean. This new ophthalmosaurid is named Sveltonectes insolitus. This nearly complete holotype skull is strikingly intact. We pan from the tip of the rostrum to the dark orbit, revealing its three-dimensional preservation. Despite this condition, the specimen arrived with a major scientific complication. A private collector acquired it in the 1980s without any recorded geological context. Without a firm stratigraphic context, a fossil cannot support a new model of evolutionary history. The researchers first had to establish the skull's authenticity and precise age through forensic analysis. To find that age, the team extracted samples of the original sedimentary matrix directly from the skull cavities and the phalanges. They used fluoric acid to dissolve this matrix, isolating microscopic organic remains, specifically the preserved shells of marine algae known as dinoflagellates. The sample yielded a high diversity of microfossils, containing 35 distinct dinoflagellate taxa. By plotting these species on a biostratigraphic timeline, the researchers looked for a chronological intersection. While some species existed for millions of years, the presence of T. svedonensis and P. paliferum limits the window of possibility. The overlap of these specific indicator species anchors the skull's age to the late Barremian. This paleontological profile also served as a security check to ensure the entire skeleton belonged to a single individual. During this process, the team analyzed a single vertebral centrum appearing slightly larger than the rest. Its internal matrix revealed a different profile of organic particles and sediment. Because the microfossils did not match the rest of the specimen, the team identified the bone as an artificial addition and removed it from the study. This forensic validation provided the evidentiary foundation to begin a formal anatomical analysis of the specimen. With its age and authenticity confirmed, the focus shifts to the morphology of the skull to determine where the animal sits in the ichthyosaur family tree. This drawing shows a slender premaxilla at the front of the skull, its height decreasing abruptly near the external nares. Unlike other ophthalmosaurids, Sveltonectes lacks a processus supranarialis, leaving the dorsal border smooth. Further back, the nasal bone features a prominent descending process. This bony hook plunges downward until it nearly touches the floor of the nasal opening. The result is a physical barrier that effectively subdivides the external nares. This extreme subdivision of the nares serves as a primary autapomorphy, providing clear evidence of a distinct genus. Looking below the nares, the teeth embedded in the maxilla and dentary provide evidence of the animal's hunting strategy. The tooth length index measures the size of the teeth relative to the jaw. Sveltonectes has a remarkably low index of 0.15. In this macro view, we see that the individual teeth are minute and sharply pointed. Some even show a slight recurve. This dental structure is the opposite of the robust conical teeth found in Platypterygius, the dominant predator of the era. These delicate teeth functioned exactly like needles, perfectly designed to snare and grasp small, agile, soft-bodied prey. Using such a fragile bite to crush hard shells or attack large vertebrates would have resulted in immediate dental failure. This specialization shows that early Cretaceous ichthyosaurs were successfully exploiting highly specific, non-competing ecological niches. Moving into the interior of the skull, the basic cranium, or brain case, reveals even more specialized bone architecture. The basioccipital bone features a deep anteroventral fossa, and the surrounding basipterygoid processes are reduced to short rods. However, the most significant find in the brain case is located on the left proatic bone. Its anterior lamella is pierced by a cylindrical mediolateral foramen. In modern reptiles, a hole in this precise position serves a specific biological function. It allows for the passage of a critical neural pathway. Specifically, it houses the facial nerve, which is also known as cranial nerve 7. This foramen is a primitive feature common in ancient Triassic ichthyosaurs like Mixoris. This is the first time a propilotic foramen has been identified in any post-Triassic ichthyosaur. The retention of this ancient neural architecture suggests that the evolutionary history of the ophthalmosauridae is more complex than previously thought. Stepping back to the orbit, we find bony plates that supported the animal's eye. The sclerotic ring consists of at least 10 trapezoidal plates, each marked with radial striations. While the orbit itself is large, the central aperture, the opening for the pupil, is exceptionally small, occupying only 12% of the orbit's area. This is a significant departure from adult Ophthalmosaurus specimens, where the aperture reaches 20%. This restricted opening suggests visual adaptations specifically tuned to the light conditions of its hunting environment. When combined, the subdivided nares, the specialized teeth, and the ancient nerve pathways define a unique biological profile. Based on these 11 unique anatomical traits, the researchers have established Sveltonectes as a distinct genus. Phylogenetic analysis places it as the sister taxon to Ageirosaurus, branching off the Thunosaurian line during a period of early Cretaceous radiation. Its name, Sveltonectes insolitus, reflects its biology. It means the unusual, nimble swimmer. This streamlined build and specialized anatomy indicate ichthyosaurs were still actively diversifying in the late Barremian. The presence of Sveltonectes alongside Platypterius reveals a stratified marine ecosystem, where apex predators shared the Barremian waters with highly specialized hunters. The ophthalmosauridae did not simply decline toward extinction. They remained a diversified and ecologically significant group through the final stages of their evolutionary history.